Astronomers often tell us that. How many million light-years away is a certain star? How many times the mass of the Sun? Now, many people have questions. These stars are so far away from us. How do astronomers know about stars? In fact, although the stars are very distant from us, but astronomers have discovered multiple methods to reveal the secrets of these distant stars. As calculated, the method of mass is Kepler's third law. Suppose a planetary system is a binary system. That's to stars. Then by observing orbital period and semi-major axis of binary systems, the sum of the masses of the star can be lifted. If T can be measured separately, the orbital radius of a star, the respective quality can also be further determined. But Kepler's third law just uses binary star systems. And if it is a single star system, then we need to analyze the stellar spectrum. The so-called stellar spectrum are stars, surface light intensity, the relationship between degree and wavelength of light. The spectrum contains information about stars, information on various characteristics. The shape of the spectrum determines the physical properties of a star, chemical composition. Therefore, differences in the spectral types of stars reflects the properties of stars. Astronomers have discovered in long-term observations, the more massive the star, the more luminous it is. The higher the temperature, that is to say, luminosity through stars, we can roughly estimate the mass of the star. Currently, our most commonly used star spectral classification system. It was the Harvard Observatory in the late 19th century. The proposed Harvard system. The Harvard system divides the spectra of stars into OBA, FGKM and other types, such as the O-type spectrum. The temperature of the star is 30,000 - 60,000 K. The color appears blue. The mass is about 20 to 260 times the mass of the Sun. Terrain spectrum star. Temperature at 10,000 - 30,000 K. The color is blue and white. 3.2 to 19 times the mass of the Sun. A type spectral star. The temperature is between 7,500 and 10,000 K. The color appears white. 1.8 to 3 times the mass of the Sun. F-type spectral star. Temperatures between 6,000 and 7,500 K. The color is light yellow and white. 1.2 to 1 times the mass of the Sun. Giant spectral star. Temperatures between 5,000 and 6,000 K. The color appears yellow. 0.9 to 1 times the mass of the Sun. K-type spectral star. Temperature between 3,500 and 5,000 K. The color appears orange. 0.8 to 0 times the mass of the Sun. M-type spectral star. Temperature below 350 K. The color appears red. The mass is generally less than 0.5 times the mass of the Sun. We can tell from the spectral type of the star. The Sun is a giant star. So the Sun is also often referred to as a yellow dwarf. By analyzing the spectra of stars, not only can we know the quality, we know the lifespan of stars. According to astronomers' research, the lifetime of a star is inversely proportional to its mass. In other words, the more massive the star, the shorter its lifespan. Less massive stars live longer. We know the principle of star luminescence make the internal nuclear fusion reaction. Due to the small mass constant, the internal temperature and pressure of a star are small. nuclear reactions will be relatively mild and large mass. The temperature and pressure inside a star are higher, make nuclear reactions violent. In a violent nuclear reaction, fuel will be consumed too quickly. So massive stars are very short-lived. The lifespan of a supergiant like land, just a few million years or so. And infrared stars can live for hundreds of billions of years. So by analyzing the spectra of stars, to determine the remaining lifespan of a star, so the mass of the star, how are the distances of stars known? Although these celestial bodies are very distant from us, but we can still get through. There are many ways to determine the distance between them. The first is triangulation parallax. The triangular parallax method is generally used measuring stars within 100 light-years of Earth. And it needs to use the Earth orbits as machinery. Because the Earth revolves around the Sun, will form a circular orbit. And we were there between January and July. Record the location of a star. Then the two observed changes in the position of the star. Parallax intersection. You can calculate the distance to the star. The second is to benefit variable stars. Paradiers are a strange kind of star in the universe. Luminosity changes periodically. It will brighten up within a certain period of time, and then it darkens. Brighten up. This period we call the light variable period. And the longer his light cycle is, the greater the luminosity. Astronomers use the light cycle to estimate, calculate the benefit, absolute magnitude and apparent magnitude of variable stars. Then you can calculate the distance. The third one is the Haber-Redby method. In the 1920s, an American astronomer named A.I. Devin Haber, when observing distant celestial bodies, a phenomenon was discovered. That is, most galaxies have a red meter phenomenon. The so-called red meter phenomenon is when a celestial body moves away from us. The wavelength of light gets longer. The color of the spectrum will move towards the red end. On the contrary, the wavelength of light approaching us becomes shorter. The color of the spectrum shifts towards the blue end. It's called the blue-meter phenomenon. From this, Hubble concluded at that time most of the galaxies are moving away from us, and also found that the farther away the galaxy from us, the faster the regression. This means that we just need to measure the red graph of the galaxy, and we get the regression velocity to know how far the galaxy is from us. So astronomers tell us that how many light years is a certain celestial body from the Earth? How big is the quality? It's not guesswork. It's calculated through various methods. Although there are certain errors in these methods. But with the continuous advancement of science and technology, I believe that the future will be more accurate.